Hey guys, welcome back to another video. So in this video, I'll be talking about electrolytes, the different kinds of electrolytes, and using this concept in net ionic equations. And there'll be a lot more other concepts branching out from this, but this is a really main topic that we should focus on. So first, let's look at exactly what an electrolyte is. So basically, an electrolyte is a substance. It's a substance where if you put a current through it, it forms a charge. And so there are different kinds of electrolytes. Different kinds of electrolytes. They're strong and weak. Strong, weak. So in a strong electrolyte, let's go here and let's choose a better color. So let's say you have AB and you put this in an aqueous solution. Put this in an aqueous solution like water. A strong electrolyte, if AB were a strong electrolyte, it would form A plus and B minus. And there will be lots of these ions. However, let's say AB was a weak electrolyte. Then in solution, there will be a lot more ABs than A plus and B minus. So there will be a lot more of the whole molecules than the separated ions. So let's first talk about strong electrolytes. So strong electrolytes can be essentially put into three categories: strong acids, strong bases, and soluble salts. So all these substances ionize in aqueous solutions. So it forms these separated ions. So let's talk about all the strong acids and all the strong bases and all the soluble salts. So for the strong acids, there's HCl, HBr, HI, nitric acid, chloric acid, perchloric acid, and sulfuric acid. These should basically be committed to memory. Being able to determine which electrolyte is strong and weak is extremely important. Now let's look at all the strong bases. There's lithium hydroxide, that, and that. So these are all the strong bases. So there's also a weak acid and weak base. Those are weak electrolytes, thus the name. And if you want to know whether an acid or base is weak or not, just look if it's in the list. If it's not in the list, then it's weak. These are all the strong bases and strong acids. There are a lot more weak counterparts, so it's just important to sort of commit these to memory, and then you can just figure out the rest. Solubility of salts. There's something called the solubility rules. I won't really go much into detail of this because this is also a memorization thing. It's just a Google search away. These solubility rules basically say that if an ionic compound has a specific cation or anion, it's either soluble or not. So an example of a solubility rule would be like nitrates are always soluble. So there'll be little rules like this that tell us if it's a strong or weak electrolyte. And so the reason we care so much about strong electrolytes, for instance, is like, let's say there's like this is a circuit, and the substance, one of these strong electrolytes, is in this container, and then we place a current through this. This is just a simple circuit. Then this will light up really brightly. Essentially, what this tells us, that when a compound is really ionized, a current passes. When a current pass through it, there's more of it. So if it's a weak electrolyte, so anything other than this, it won't burn. It won't be as bright. It would be really dim. So now let's talk about how this plays in to net ionic equations. There you go. Okay. So net ionic equations, they tell us essentially what's taking part in a reaction. So for instance, let's have a reaction here. Zinc chloride plus this. And they want us to know what's the net ionic equation. So like I said before, a net ionic equation tells us what takes part in the reaction. So we have to first decide whether these are strong or weak electrolytes. Zinc chloride, for instance, based on the solubility rules that I'll have attached below, this is strong. So this will thus be in its ionic form. Same here. This is a strong base, so we can do the same thing here. Now we have to be able to determine what the products are. This is just a simple double replacement reaction. So we get zinc hydroxide, and now we should balance this. That should be our reaction. So we'll add it here. Now let's do the same thing here. Let's determine which one is strong, which one's weak. So zinc hydroxide isn't a strong base. It wasn't in the list that I mentioned earlier. So we can automatically tell that this is a weak base. And so we don't ionize this. We don't ionize this. So this is just in its solid form. But this is a lot different. Again. This is a soluble salt. So what this gives us is we're able to now delete the ions on both sides. So let's see here. We have potassium plus. We can delete that. Chlorine minus. These ions that I just deleted are called spectator ions. Spectator ions are ions that do not take part in the reaction. So whenever we ask for a net ionic equation, this should not be in the net ionic equation, because these ultimately, they join in the reaction and then break apart again. So in the end, the total reaction, they just do not take part in it. So this is really important. Spectator ions do not take part. And we were able to find this because spectator ions are strong electrolytes on both sides. So let's see what we're left with. We are left with this zinc 2 plus 2OH minus yields zinc hydroxide solid. This is the net ionic equation. And for the most part, net ionic equations have a solid in one side or the other, and then the ions that form because of that solid. So this is the ultimate net ionic equation. That's the answer we're looking for. Let's work through one more problem. Now that it makes a little bit more sense. So let's say we're asking for the net ionic equation of this. I'm just going to go ahead and give the products. Once again, this is just a double replacement, so this should be fairly straightforward. Okay, we have to balance this because, of course, balancing is key. So now we want to find the net ionic equation, NIE. What is it? You can pause it now and go work it out yourself. Okay, let's do this. Okay, so like I said before, let's work with the reactant side. So are these strong or weak electrolytes? Sodium chloride is a strong electrolyte, so we can put it in its ionic form. Let's look at magnesium nitrate. Based on solubility rules, this is a soluble salt, so we can also ionize this. Oops, I think I'm gonna run out of space soon. So let's do this. So this is reactants. Let's look at products. Is sodium nitrate, that's a soluble salt, so we can do the same thing. And then this is also a soluble salt. So we get something fairly interesting here. Something fairly interesting here. So these are exactly the same. In reactants and products, they're all ionized. So essentially, all these are spectator ions. So we're not left with a net ionic equation. So the ultimate answer right here is there's no net ionic equation. All these ions just join together in one fashion or another and then just get solvated again. So in the end, there's no precipitate forming, there's no solid forming. All these are soluble, and we're just left with a bunch of floating ions in water solution. And so that's the answer. No ionic equation. I just wanted to throw a curveball out there just to show you some of the questions that could be there, because the last problem I had was fairly cut and paste. It can be used in a bunch of situations. So yeah, that was this video. Thanks so much for watching. Make sure to hit like and subscribe. Also, check out my website. It'll be a lot more thorough than this. Take care.